Ladies and gentlemen, welcome back to another video. So in this video, I'm going to show you how to create a random terrain that it's cool actually generate a random terrain, but well, not purely random, but its randomness, it's smooth, like a smooth terrain out of blocks. So anyway, let's start. By the way, before I will start, I want to thank you for 1000 subscribers. Thank you so much. I really appreciate it. And sorry for this inactivity. I'm really way too busy with school. I don't know even how I made this video. So anyway, let's dive right in. First of all, I don't need this base plate because I'm going actually to generate my own terrain. And I'm gonna make some blocks. I'm gonna make a grass block first. So I'm just gonna go to the size. So I just made a part here, and I'm just gonna make the size of it 4 by 4 by 4. You can choose whatever size you want for the blocks, but I'm gonna choose 4 by 4 by 4. So anyway, let's do grass. Grass. Where is grass? All right, there we go. Cool. It's looking pretty good right here. Alright, so I'm just gonna call it grass. And well, I'm gonna make a folder in replicate storage. I'm gonna call it blocks, or name it blocks, just like that. And I'm gonna put my little grass block on it, of course. So here we have a blocks folder inside the replicate storage. Inside it, a grass block. So we have right now just one block in the storage that we can use in our script. So now let's create our script. Alright, now we're gonna begin the hard work. So if you remember my last, well, not my last, I think, anyway, my previous video, I made a smooth terrain. Well, it was flat. It was just flat, a flat cube terrain, or out of cubes like that, out of blocks. But now we're gonna use a smooth. We're gonna do a smooth terrain. So let's do it. First, I'm just gonna do created by Kozutako, just for the credits. Anyway, you don't really need to make this. I just like to do it as a comment for any script that I make. So yeah, cool. Now we're gonna have a loop, or actually I'm just gonna do a function create block, or well, create block, right? We're gonna give it like the block name and x, or actually position, or pose for shirt. And yeah, that's it. Alright, and I'm gonna have actually in the workspace a model called, well, let's say smooth, or actually Terra, for example. Why I didn't want to actually name it or call it terrain, because there's already a terrain object on the workspace, so I don't really want to get into that trouble of overlay. So anyway, local Terra equal to workspace dot Terra. Cool. And I'm gonna get our storage of blocks that we put in the replicate storage, local rs for shirts for the replicate storage. And I'm gonna do game get service replicate storage. Alright, good. And so now it's good. So we're gonna have local terrain size. I'm gonna have it as vector 3, and I'm gonna give it the size of our terrain that we want. So 10, 0 for right now, just for now, and 10 for the z. I'm going to tell you what this means in a second. Just don't worry about it right now. We doesn't gonna make into it right now. So anyway, so this function create block just gonna create a block from the name that it's given into the right position. But here, it's gonna actually check for if there is any block on its way, like if there is any block on that specific position. And well, for that we're gonna name our block in a formatted way like its position. So I just gonna have a really simple or easy way to check positions or collisions actually. Or actually we can go with another way. I think it's called region tree in roblox, right or not? Find part in region, if I'm not wrong. Roblox. Well, from crossing a border. Alright, the gray part is supposed to be a region tree too. Well, let's just make that for now. So first of all, we're gonna get the block that we need. So we're gonna search for the block in our blocks or our storage of blocks for the name that we given from the function. So I'm just gonna do, well, I didn't actually get a variable for it first. So local storage, for example, equal to game, or actually we have rs, so replicate storage, find first child blocks. Well, it's safer to wait for child or wait for child. Alright, local block equal to storage, find first child, block name. So we're going to get the first child that it's with the name that it's given to the function. So we're gonna check if there is that block or not, else we're gonna error, or actually, well, error this block name doesn't exist. Alright, cool. So now if we try to address a block that it's not there, let's try it here. For example, that string, that block, that it's none, well, it's not there. There's just a grass block right there. So vector tree.new, even we don't need it actually. So anyway, I just want to show you the output or the error that you're gonna get. So test run, and here is my output. So what? This block doesn't exist. Cool. So yeah, just good right there. So now let's actually work on it. So here we're gonna do block equal to block clone. So we're gonna clone, we're not going actually to manipulate this block or that block from the directly into the storage. Well, we're just gonna get a clone or a copy from it. So yeah, that's what I'm doing here actually, block clone. Right, now I'm just gonna change its position. So block.cframe equal to cframe.new, and then I'm gonna pass in the cframe the position that we got as a parameter, and then I'm gonna set the parent of this block into works, or actually not workspace, so Terra, this model that we created here. So now I'm just gonna say for safety, or actually for safety, so I'm just gonna do in documents, maybe I'm gonna call it smooth terrain. And it's a good habit to actually save your work from time to time so you don't lose it. So I didn't call actually the function yet, so let's call it. Let's create a block with the name of grass in the position 0 0 0 0. Alright, run, and there we go. But it's falling down, so I should anchor it. Well, I can anchor it directly in the storage. Just run it right now. It looks great as we wanted it inside the model Terra, and it's position 0 0 0. Alright, now let's actually go into creating some more functions. Well, here another function called create chunk, for example, right now. So create chunk position, so the chunk position, and well, local chunk size equal to vector tree.new 16,0,16 as Minecraft, if you do notice. So anyway, create chunk in this right position. Cool. Now we're going to create, well, a loop for x, or actually, well, let's go with for x, comma 0, or actually pose dot x. Well, this is the starting position of our chunk, so pose dot x, comma pose dot x plus chunk size dot x, comma 1 do. I know it would be a little bit strange to you, but I'm going to explain it later, don't worry. And I actually explained it in the last or the previous video, but here just a little bit of added math and the added variables. So yeah, I know. So let's just do it. For y equal to position dot y, comma position dot y plus chunk size dot y, or actually, well, not dot y, dot z. Let's tell it for z. I'm sorry for that. So position dot z plus chunk size dot z, comma 1 do. So just checking. Good. It looks good. I don't know. It looks good until now. So now we're going to create a block in that specific position that we got from this x, comma y. Well, I'm just going to do a local y equal to 0 for now, comma z. And I actually forgot about the block name. Well, wait, grass, comma vector tree dot new in the x we're going to have x, comma y, comma z. Alright, cool. Now let's try. We're gonna have a bug, I know that, but just checking if the syntax is good or not. And well, what's happened? Well, nothing happened. We should know why. So let's see the output. Doesn't look like there is any output here, right? Well, great. Anyway, let's see what we got here. Position.x. Well, let's see. Well, actually, I didn't call the function, so let's call the function create chunk vector tree dot new 0, 0, 0. Right. So now let's just test, run it, and well, there we go. But we have just a little bug here. We're incrementing by 1, and well, this block is a size of 4, not just 1. So we should scale that positions that we get into the size. So that's it. Come on, 4. Or actually I can get it into another variable. So local position equal to this. I'm just gonna give in pose here. So let's see. Now we have a 16 by 16 chunk. Well, you can tell 17 by 17 actually, because we're counting from 0, I think. So select children. 289. 289. Well, square root. Well, 289 square root 17. Alright, as I told you, there is 17. We can actually get this right by just decreasing one number, -1, and here 2, -1, just if it matters, because well, we want some precision here. So now what about now? Select all the children, and we have 256. And yeah, it should be its square root. It's going to equal 16. 256 squared, or square root of it. So 16, as you see. Cool. Now we have got just our flat terrain as the previous episode. So now what we gonna put into this y value to actually make that smooth transition between blocks? Well, we're gonna use a function called math.noise, and well, for this function we're going to make some variables. Well, first of all, scale. Well, actually we can use, or never mind. So local scale equal to, let's do 15 for now. Local frequency equal to 15 for now too. Just temporary, we are going to choose the best that we want. So, and local resolution, I think. So yeah, equal to 16. Not sure about this, but let's see. So math.noise, the number x. Well, the number x, we're gonna give it the x position. Well, actually, maybe I'm going to go, never mind. So math.noise x comma y, and here we're just gonna do a random value, seed, local seed equal to math.random minus math.huge comma math.huge. Well, math.huge, it's like infinity. Well, here I'm taking a number between -infinity and infinity. Alright, cool. so we get a variety of seeds, and that's why I'm doing that. So and we're gonna pass in the seeds. So here actually x by scale, I think, or frequency. Well, frequency, and y by frequency, and here times scale. I think that's it. Well, here z, and well, I don't think we need this resolution. I'm not sure where I was putting it, but anyway, scale equal to 15 and frequency equal to 15. So let's see actually how this is gonna go. Well, all right, awesome, we're getting our results right here, as you see. It looks great, not bad at all, pretty neat. Let's try to maybe get the frequency up a little, for example 20 maybe, and as you see it's a little bit smoother than before. 50 in the frequency and we get smoother, as you see. Cool. And you can play with these two values. There's a variety of stuff. It depends on the terrain that you want to actually generate. And yeah, so frequency, let's actually go with scale. So scale adjusts the size of the variation. I mean, well, you're just gonna scale it. So for example 100 in the scale, and as you see we're getting bigger and bigger. Let's do 50 in the scale, and well, see, and if I did 1 in the scale, well, it's just going to be a difference of 1, and it's not even obvious to see the difference between the position of the blocks. It's pretty hard because it just a 1, just scaled by 1. What about 5? And now you see, let's play with the frequency a little here. 16 for example, run, and as you see, you just play with these two values and you're getting several terrains. And now maybe it's time to start or to begin with the function create terrain. Alright, well, we don't need actually a position, so yeah, for x equal to 0 comma, well, terrain size dot x comma 1 do, and well, I'm just gonna subtract a 1 here so we get the value precisely because we're counting from 0 not 1. And for z equal to 0 comma terrain size dot z minus 1 comma 1, well, minus 1 comma 1 do, and yeah, and we're going to create a chunk here. Vector tree dot new x comma 0 comma z, run, and well, wait, we're not creating a terrain. We should call the create terrain thing. By the way, we should wait. Just going to wait a little here so we don't get lagged out. And how much is the terrain? It's 10 by 10 chunks. Alright, as you see, we're generating some chunks and it's getting laggy. Well, I think there is a problem right here. Well, first of all, I'm going to get down the chunk size to 2 by 2. And let's see, I think it's overlaying with each other. Right, it's overlaid. So I think I'm gonna have 4 grass blocks. Yeah, I see what's going on. It's getting on the way. Alright, I should actually scale this position of the chunk to the chunk size. I think that's the problem. So let's see. But it looks like it's the same or not. Not really sure about that. So let's just select the children. We have 399. I'm not sure about this. Delete. What's going on here? So script, we created the chunk in this X and in this Z, and well times chunk size. Alright, if we actually doubled that or added, well, doesn't gonna make any sense. Not sure. Let's do for 2, 0.2. Let's try this. But is this the chunk really? I think I got the problem because I actually changed the chunk size, well, not the terrain size. I'm a dump. I'm really a dump. So let's see right now. As you see, we're getting 4 chunks. I'm just gonna delete that here. And it should be good right now. Alright. We have 4 chunks right now. That's good. Well, every chunk have 10 blocks, I think. Yes. Well, 10 blocks times 4. So let's select the children. Well, 10 times 10, it's 100. Times 4, it's 400. Okay, so as you see, we're getting the result. Good. And we have this cool smooth terrain. But be aware, make sure to don't get like a big numbers right here in the chunk size and the terrain size. Well, let's actually get a little bit bigger and see how the performance is gonna even go down. I have a, well, not a good PC, just 4GB RAM, 2 processor, well, dual core processor, 1.6 GHz, Intel Pentium, and as you see, it's already ne répond pas. Like it's crashing now, but it's working. Alright, we're getting some cool results. Really cool. We have right now just one block. We can add more. But just look at this freaking cool terrain. That's just awesome. And well, I'm gonna end this video right here. Thank you for watching. I'm sorry if I didn't explain this for you all like as needed to, maybe because I feel like you didn't understand or something, I don't know. Yeah, I know it's a little bit complicated, but trust me, when you get into it, you're going to begin to understand. First of all, you should actually research about this function that it's called math.noise, and why I actually did well, it's actually all math. It's really hard, like, to explain math, and well, I'm not a math teacher to explain that. So yeah, there's a lot of videos out there to explain like this stuff, and you really should have a good fundamental stuff in math if you want to get some advanced and complicated topics as this one, or as this smooth generation things. It's not really a big math, but you should understand the concepts, what's going on, and the logic, what's going on here. So anyway, see you later, and thank you for watching again, and yeah, bye.